The main topic of this section is one-to-one functions. One of the reasons why we want to begin studying these types of functions is so that we can define inverse functions. Inverse functions are going to be needed to describe the relationship between logarithms and exponentials. Let's go ahead and look at what we'll be covering in this section. So in the first part, we'll be looking at the definition of a one-to-one function. And then in part B, we'll see how to define the inverse of a function given that it's one-to-one. And then in part C, we'll focus on finding the inverse of a function. And then finally, in part D, we'll go ahead and see how to graph an inverse function using a transformation. Let's describe one-to-one function using some pictures real fast. So over here we have two different functions, a red function and a blue function. And this is really highlighting the difference between a function and a one-to-one function. The function on the right-hand side, what we see is the following. We have two different input values, namely B and C, and both of these input are assigned to the same output. Which is E. This means that the assignment of an input to an output is not unique, and this is an example of a function that's not one-to-one. On the other hand over here, each input is assigned to a unique output. And this is an example of a one-to-one function. A one-to-one function is just a function where for each input we send it to a unique output. Which really means the following. Functions are this general class over here, and one-to-one functions are a special subclass of functions. And what we know is that every one-to-one function is in fact a function, but not all functions are one-to-one, as we just saw in the previous example. And again, the main property of a one-to-one function is that each input is going to be sent to a unique output.